Hi, in this video we will learn a new form for complex numbers called polar form. And then we will see that this form will be useful when we're trying to find powers of a complex number, and that's where the De Moivre's theorem come in. Okay, so remember that in the complex plane, every complex number can be identified by a point. So if we have real part A, complex part B, then BI, then the point AB we denote it by A plus BI. But this is not the only way we can identify that point. We can identify that point using the angle that the line connecting the point and the origin makes with the positive x-axis, and the distance of the point from the origin. So here the distance, we have a notation for that. Actually, that's absolute value of z, and we denote, well, the value of that is square of a squared plus b squared. How about theta? Theta is the angle that if you find the tangent of that, you will get b over a. And well, when you try to write this, you notice that here a is going to be related to the cosine of theta. You see that a over r is going to be equal to cosine of theta, and sine of theta is equal to b over r. So from there you see that a is equal to r cosine theta, and b is r sine theta. Then our complex number z, a plus ib, can be written by r cosine theta plus I times r sine theta. And then you have r cosine theta plus I sine theta. And that is how you have this new form, the polar form of complex number z is r times cosine theta plus I sine theta. So that's called. So we have to find the length and the angle. Let's do some example. Find the polar form of the given complex numbers. Okay, first one is 1, z is 1 minus I, and the second one is z is equal to root 3 plus I. Very nice. We need to find r. R, in as always was mentioned, is absolute value of z, which is real part squared plus imaginary part squared. Then find the square root of that. So it's root 2. How about theta? So theta is an angle whose tan is equal to b, here is -1, the imaginary part, over the real part, -1. So what is the angle whose tan is -1? Well, you can do a little bit more work here. For example, you see that a over r is cosine of theta, yes? And in this case, we have 1 over root 2, which is root 2 over 2. And you know that the angle whose cosine is root 2 over 2 is going to be Well, either pi over 4, sorry, or negative pi over 4. Why negative? You see that the sign of this guy, which is b over r, is a negative number. And that means that the cosine is positive, sine is a negative. That means that the angle is going to be in the fourth quadrant, and in this case theta is going to be minus pi over 4. What does this give us? So we found r, we found theta, then z is equal to root 2 times cosine of negative pi over 4 plus I sine of negative pi over 4. And that's what we have. The second one, this one is, well, r is real part squared plus imaginary part squared, and then square root. This is 4, this is 2. Well, a root 3 over r is equal to cosine theta, and imaginary part over length is sine theta. What is the angle whose cosine is root 3 over 2 and whose sine is 1 over 2? From here, right away, you can see that theta needs to be pi over 6 or 30 degree. And, well, we have r cosine of pi over 6 plus I sine of pi over 6. Why is this important? Why do we need to have this this form? Well, the important part comes from the fact that de Moivre's theorem says. It says that if z is equal to r cosine theta plus I sine theta, then for any integer n, z to the power n, you have r to the power n, and then you can write a polar form of z to the power n. This will be cosine of n theta plus I sine of n theta. So the power of z for any, let me write here, for any integer, positive integer n. What it means is that, okay, so if you have the polar form of a complex number, finding powers of that is easy. You have to power the absolute value part, r, and the theta that appears in the polar form, you need to multiply it by n. Well, let's then find the example. Find what? The 1 minus I, the ones that we found, 1 minus I to the power 5, and root 3 plus I to the power 10. Okay, so here we already found the complex, there's a polar form of this guy. So this is what we have. So let me just pick it from here and bring it down here. Now we want to find power to the power 5. To the power 5 means that we need to find root 2 to the power 5. then cosine of not negative pi over 4, but negative 5 times pi over 4 plus I sine of negative 5 times pi over 4. Well, this guy will give us root 2 to the power 5. Well, I can write this as root 2 times 4. Then cosine of negative pi, 5 pi over 4. This is same thing as cosine of 3 pi over 4. And that is negative root 2 over 2 plus I. Sine of, again, this guy is same as sine of 3 pi over 4. And then sine of 3 pi over 4 is root 2 over 2. And what this gives us is that we have 4 times root times negative root 2 over 2 minus I 4 times root 2 times 2. And as you can see, these will cancel each other, minus 4, and that will give us minus 4i. So 1 minus I to the power 5 is negative 4 minus 4i. Okay. How about this one? Well, we found that the polar form of this is 2 cosine of, we just have it here. Oh, let me delete that part. Yes. So this guy. Yes. To the power now 10. The Mohr theorem says that this will be 2 to the power 10 cosine of 10 pi over 6 plus I sine of 10 pi over 6. This is, well, let me just write 2 to the power 10. And cosine of 10 pi over 6 is cosine of 5 pi over 3. But 5 pi over 3 is going to have a same cosine as cosine of negative pi over 3. Okay, so that will give us 1 over 2 plus I. And this guy is again sine of negative pi over 3. And that will give us negative root 3 over 2. And then you multiply, you get 2 to the power 9 minus root 3 times 2 to the power 9i. That is how we find the powers, at least integer powers, of a complex number. And you have to know how to go to the polar and then find the power from there.